Alright, good afternoon everyone. We're going to go ahead and start talking about kinetics overall. We want to sort of get an idea of how the reaction happens. In the past we've talked about, I've given you a reaction, asked you to finish and say what products will be made and to balance it and all those different things. But now we're actually going to go into the overall reaction and determine how it's going to take place, how we're going to form those compounds that we spoke about. What are the things that affects the formation of those compounds. So our first learning goal that we're going to deal with is to be able to define kinetics and the rate, reaction rate. Now, kinetics overall is the area of chemistry where we're going to look at how fast and how the reaction takes place. Now, for the rate of the reaction, it's usually going to be measured by the decrease in concentration of one of the reactants or the increase in concentration of one of the products. Well, what do I mean by this? We'll go back here. If I'm looking at, let's see, will it give me an opportunity to do it? No, it won't. It's okay. Now, if I'm looking at, and I'll draw it right here in the top corner, if I have this graph for reaction taking place, as I have one of my reactants, usually I'm going to start with a concentration, say, somewhere up here. Over time, what's going to happen is that concentration is going to drop, and then it's going to hit a point where it sort of levels out. When it hits that point that which it leveled out, or where it's completely gone, we should also be able to look at that and see the formation of our products. So I can change my color here. Do that. This would be the formation of my product. It's going to have a very similar situation here. It's going to increase and eventually it's going to keep going. Now, sometimes this will overlap, sometimes it won't. But the overall idea is we're looking at, if this is my time, if this is my time, I'm going to look at how the concentration is going to change over that certain period of time. Now, given this example, we want to make sure that we pay attention to the algebraic sign. If we're looking at the disappearance of the reactants, we want to make sure that there's a negative sign given out front. Whereas if we're looking at the appearance of our products, we're going to have a positive symbol, or we just won't have to have a negative symbol there. So in terms of what we're looking at here, if I want to do things in terms of disappearance of A, I just need to make sure that I put a negative sign outside the change in concentration of A over the change in time. But if I'm looking at the change in, or the appearance, of C and D, it's going to be a positive value. Why? Because it's coming in, it's going from 0 and going up, whereas the other one is disappearing and going away. Now, what do we do with the coefficients? Basically, the coefficients are there that help us to understand how the rates will compare between the compounds. So, in the situation that we're dealing with here, B is actually going to disappear twice as fast as C or D appears. So if we're making comparisons between those two, we can make the adjustment of this. So we can say the rate equals the negative change in delta A over the change in time, which also equal half the negative change in B over the change in time. And C and D, of course, are the same way as we talked about before. Now, throughout this, you're going to see I have some spots where we have free response questions from previous AP exams. We're going to use these in class to sort of make sure that we understand the concept and that we can apply it long term in many different situations. Now, there will be some times where we want to figure out what the rate is at a specific point in time. And we're going to do this by plotting the concentration against time. So again, we're going to have our graph. So let me pull up my thing. So this is my graph. You have the concentration over time happening here. If my graph goes like this, and I want to figure out what was the rate of reaction at this point, what I'm going to do is I'm going to get the negative slope of a tangent line at that point. So let's take a look. If I have, and I apologize, a tangent line is going to touch only at that main point. Now I apologize for my horrible drawing, but what I'm going to do is I'm going to get the slope of that line, the rise over run. So change in y, y over change x. And this is going to be the negative slope of that line. That'll give me the rate at that point in time. Now, you can also look on page 554 for the diagram. You're going to see something very similar to this, and this is better than my drawing. If I wanted to know for this specific time, I can draw my tangent line, get the rise over run for that area, and that will give me overall my rate at that point in time. We call that the instantaneous rate. Now, how do we usually have our units represented here? Our units for rate are usually going to be molarity over some unit of time, or as you see here, we make things a lot easier, mole over liters times time. This is going to be very important, especially when we talk about calculating our units for K, which is going to be our rate constant. But this is where we're going to end this part of the video, and I will see you in class. We will continue our discussion and work on our practice to make sure we understand it. Have a good evening, and talk to you later.